Alrighty, so this is part 2 of the crash course. We went over all of the different rules and all the different principles of the exponents. I broke it down. If you really want more of a detailed explanation on how to do some of these problems, I've got dozens of problems that I've done, a dozen of assessments that I've finished. You can all download them and review them on Canvas as we go. But this is going to be crash course part 2. Hopefully you kind of figure out where I'm going with this. So, simplify the expressions, positive exponents only, we'll get into that. We'll definitely get into that. So we have, first question is x to the third raised to the sixth power. So this is, again, the only time we are ever going to multiply exponents is when we've got a pair of parentheses and we've got an exponent outside that parentheses. So that's going to be a direct application of the power of power rule, which is x to the a times b is equal to the x to the a times b. So with this one, I've got x to the third raised to the sixth power. So that's going to give me immediately, I'm writing down the base. First things first. Before I do anything else, I'm writing down the base because this operation is not going to eliminate my base. So that gives me x to the 3 times 6, because it's a times b. That's going to give me 3 times 6. That gives me that, which is equal to x to the 18. That's the correct final answer. Again, you see parentheses, you see an exponent. That's the only time you're going to be multiplying. Every other time, it's going to be addition and subtraction. Speaking of which, so remember what when I went over with the basics in part 1. Anytime you see the division sign, you are going to be subtracting. You are always going to be subtracting when you see this division sign. So I'll start out writing down all the bases that appear in the problem. There's 1. Now I know I'm going to be doing my quotient rule, because I'm always going to be subtracting. And because I'm always going to be subtracting, I take the top number, 13, minus, notice how I wrote down minus before I even looked at the bottom base number. That's because you're always going to be subtracting when you're using the quotient rule. So 13 minus 4, that gives me n to the 9, and that's my final answer. I'm not going to hold folks to this, but I would really like to see explicitly how, if you get the answer, how did you get the answer? Which rule did you use? How did you set the equation up? Because sometimes there's just like one number off, and I can be like, okay, yeah, they've got the general idea, they just made a calculation error. But if you just wrote down like n to the 8th because you made a calculation error, that's a wrong answer. And if you don't have this written down up here, I can't tell where you were with this. So again, you see a division sign, you know it's going to be a quotient rule, you know you are going to subtract. You are always going to subtract whenever you see this. So n to the 13 over 4, so that gives me n to the 13 minus, now I look at the bottom of it, 4, gives me 13 minus 4, which is 9. All right, this one's going to throw us for a little bit of a loop because we've got that negative exponent. Does that mean that the numbers become negative? No. It does not mean anything about the variables. It doesn't. It just does not. Anytime you see a negative number, and it's going to be on anytime you see a negative number, you want to make sure that it turns into a positive number by the very end. So we've got 2 options on how we want to do this. What I would honestly suggest you do is you get rid of the negative exponent first. If you take, so I'm going to use the animal metaphor that we have here. So I'm going to say x to the negative 4. You have your x to the negative 4. It's by the gate, and it's very negative, it's very sad. It wants to be on the other side of the gate. So what do? you let it to the other side of the gate. So you let it to the other side of the gate. The exponent doesn't change its value, it just changes its sign. So if you have a -4, so if you have a negative number of any kind with your exponent, first thing you should do is drop it down to this side here, drop it down to the side. Question becomes, well, we are going to deal with plenty of different examples, but this would just be my recommended step 1. Now, whatever I do from this point forward, I don't have to worry about moving things up or down across the gate or above the level, or above the fraction there. Now, as I mentioned earlier when we were doing the power of power rule, there is nothing that will happen with A and the 4 that will ever affect what happens with B and the 4. So I'm going to write this out as an extra step just to illustrate the relationship between the two. You're not expected to do this, but you should get the same answer eventually that I do. So that is exactly the same thing as the one above it. I'm applying, this is A times B to the 4th power. That's the same as A to the 4th times B to the 4th. Because whatever happens with this exponent, it's on that on A, whatever happens with the exponent in A, it is not going to have anything to do with the exponent in B. So that will move me to now, how do I know that that becomes A to the 4th and B to the 4th? I don't have a number there. You all should remember by now, it's been almost 5 weeks. If you do not have a number here, you can always add a 1. There is always going to be a 1 there, whether you add it or not. As long as you remember that the 1 is there, you can use the rules pretty quickly. So A to the 1 raised to the 4th power, using the power of power rule, is the same as A to the 1 times 4, which is A to the 4, and we have the same result with B. And again, whatever happened with A affected A, whatever happened with B affected B. You got to keep them separated. All right. Okay. So with this one, this is a direct application of the product of power rule. So we've got m raised to the 2nd power times m to the 4th power. Again, we do not have parentheses. We do not have parentheses with exponents. And we don't have a division line. So that means all we're going to do is add. If we don't have parentheses with an exponent, so if we don't have whatever is inside the parentheses raised to an exponent, and we don't have a division sign, all we're doing is we are adding the exponents for terms that have the same base. So this is m and m, they both have the same base. Awesome. So n times m gives us 2 plus 4. Because again, we don't have parentheses with an exponent, so we're not going to multiply. We don't have a division sign, so we're not going to subtract. That just leaves addition. So m squared times m to the 4th, 2 plus 4, m to the 6th, and that's all you need. That's the correct final answer. Let's move on to a few more complicated examples, but the thing is, you'll realize really quickly, these aren't complicated. All they are irritating, because we're basically adding variables, but we're not changing what we do to them. So like I said again, where we have extra variables, but we're not changing what we do with the variables. We're using the same rules. There's just more variables to use them on. So I'm going to group the x's together. Then I'm going to group the y's together. Now some folks are looking at the negative sign and saying, well, with that a times b to the negative fourth, why didn't you flip it over? That was basically just like a choice of experience. If you wanted to apply the negative fourth power to that a and b problem, you could, and then figure out what the negative sign was. That was really just more of a preference. Here, I'm not going to do any such thing, because here, all I'm doing is adding. I don't have a parentheses with an exponent, so I know I'm not multiplying, and I don't have a division, a over b, so I know I'm not dividing, so I know I'm not subtracting. All I'm going to do is add them together. So I've got x and I've got y. Now I just need to figure out what their exponents are going to be. 3 times x times x, 3 is equal to 3 plus 4, that gives me 7. Y times y, all I'm going to do is add their exponents, negative 5 plus 5. Uh-oh. Well, this is a little bit of a quandary here. The only time you will ever be able to eliminate a variable from consideration, okay, the only 2 times, I keep adding these qualifiers, if you have y equals 0, y to the 0 power, if you have anything to the 0 power, you can cancel it out. It's no longer part of the equation. It's no longer part of the solution. You can cancel it out, you can ignore it. If you go back to my discussion of the quotient of power rule from the crash course part 1, I also talk about how you can get rid of variables early on. We should have another example where I can talk about that, but if ever you're done applying a product rule, a quotient rule, or a power rule, and you get a 0 as the exponent, just cross that base out. Just cross that term out because you don't need to worry about it anymore. It's no longer part of the solution. And x to the 7th will be your final answer. So this is another demonstration with a negative exponent. With this one, like I said, you had a couple options. What I'm going to do this time is I'm going to, the way that I did the last one with the negative exponent was I flipped it, I put it at the bottom of the division sign, and I made this negative 4 into positive 4. What I'm going to do now is I'm going to apply the exponent just using the power rule, and just show you a different way of doing problems like this. And whichever one you feel more comfortable with, go for that one. Your goal needs to be to have a positive exponent and to use the rule correctly. So what I'm going to do, I'm just going to multiply things through directly because I've got parentheses, I've got an exponent. These are the only times, this is the only time I'm going to multiply these exponents together. So that gives me x to the negative 12th. But we can't have negative exponents. We have to have only positive exponents. Well, we can't just turn the negative into a positive. You can't do that. There's just no way that you can do that without changing a few things around. This goes back to when I was talking earlier about the animals in the gate. You set up a gate in front of an animal, like a domesticated animal, and the animal's standing on the side of the gate saying, hey, I want what's on the other side of the gate, or I want to be what's on the other side of the gate. So what do? You take the gate down, and the animal goes from being very negative and very upset to being positive. That is how you make positive exponents. That's how you deal with positive exponents that start negative. If they're whole numbers like this, you just flip them and put them on the bottom of the denominator. And that's all you do. That's the only way that, that's what we'll worry about. So that's the x to the negative 12th. So you end up a power of power rule. That gives you x to the negative 12th. It's negative because it's on the wrong side of the gate. You let it through the other side of the gate, makes it x to the positive 12th power. So you can't just erase the negative signs. You've got to do something to the number to make them go away. All right. All right. This one is a fascinating example because now we've got x to the 5th times, all right, so we're adding exponents, but it's x to the fourth raised to the third power. Oof. So what does that mean? Does that mean that, now does this third power, does this parentheses to the third power affect this term at all? No, it does not. This is its own little island. We can't combine these until we know what the exponent is that's attached to the x. The only way that we can use the product of power rule to add the exponents together, which is what I'm telling you we do in this case, is if we know what this x has for its exponent. Right now we've got 4. All right. If you really wanted to, because this is to the third power, if you really wanted to, you could go x to the fifth times x to the fourth, 1, x to the fourth, 2, x to the fourth, 3. So this is one option you can go for. And now that you have x times x times x times x, now you can use the product of power rule and get a correct answer, because all I'm going to be doing is adding exponents, because it's x times x times x times x. Now I'm just going to add the exponents using the rule, so it's 5 times 4, 5 plus 4, 5 plus 4, not times 4, 5 plus 4 plus 4 plus 4, which should give me 17. We'll hang on to that number. On the other hand, up here, let's use the power of power rule. Let's use the one time we're allowed to multiply, and let's actually multiply. So that gives us x to the fifth. I'm bringing that over because what I'm doing here with this term will not affect x to the fifth. It has nothing to do with x to the fifth. Whatever you do over here has nothing to do with what you're doing over here yet. You've got to work this out first. So that gives me x to the fifth times x to the 4 times 3. Again, power of power rule, x to the 4 raised to the third power is the same as x to the 4 times 3, which gives me x to the fifth, again, because I haven't done anything with it yet, times x to the 12th. The difference between here and here is just that I took care of the 4 times 3 and made it into x to the 12th. Well, now that we've got it in a form we can recognize, now that we've got x times x, we know we can use the product of power rule. So if we have x times x, that just means we add the exponents a plus b, which is x to the 17. And wouldn't you know it, we get the same answer, which is good. That'd be really embarrassing if we didn't. So again, you've got a couple of different options depending on how much math you want to do. Remember, you can always, whenever you see something raised to a power, you can always take the inside term and write it out that many times. If it's a positive exponent. If it's a negative exponent, you do not want to deal with that mental headache. Just use the power rule. But if you got something that's raised to a power and it's a relatively small power, you can just write it out like this and then start counting up exponents. Or you use multiplication and then add just 2 numbers instead of 4. Either way, you're going to get the same correct answer. All right, this one's ugly. This one does look pretty ugly. So don't let it intimidate you, because you know the rules that you're going to be doing in order to solve it. All this means is that there's an extra step at the end, which is going to be this raised to the third power. So until I know what I'm raising to the third power, I'm basically just going to ignore the outside of the parentheses. So for now, what I'm going to do, again, for now, I'm just ignoring the outside of the I'm just ignoring the parentheses, because I can't do anything with raising anything to the third power yet. What I'm going to do is I'm going to split these up so that I can use the quotient rule on each variable. That gives me p to the fifth divided by p to the third, p to the negative 4 divided by q to the 6th. All right. So again, I'm just resolving what's inside the parentheses first. I think that's the fastest way to go. So what that's going to give me is equal to, I've got p, using the quotient rule, this over here. Using the quotient rule, we're going to subtract. We know we're going to subtract because we've got this little gate here and a variable on the top and the bottom. So this is when we're going to subtract. We're not going to multiply, we're not going to add, we're going to subtract these. So that gives me p to the 5th, so that's p to the 5. I've been having issues with 5s for so long, but for some reason. There we go. P to the 5 minus, and again, notice I wrote the minus before I even looked at the bottom variable, 3. So that gives me p squared, so p squared. Now I'm going to do the same thing with q. Q is a little bit more complicated, but I'll show you that it's really not that complicated. That gives me q, the negative 4, divided by q to the 6th. So I'm just going to write it out exactly the same as if it's any other quotient of power rule. That gives me the base, because I know it's always going to be there, negative 4, minus, and again, I write a, however it appears, minus. Now I'm going to look at the bottom. Minus 6. Now that it's an integer operation, negative 4 minus 6 is going to give me negative 10. So, all right, so and again, now that I've got a negative exponent as part of my answer, I'm going to flip it to the bottom part of the fraction. I'm going to let it out of the gate and let it go into the other part of the field. So that gives me now a couple things to notice with this. We started out with p squared times q to the minus 10. These are two completely independent variables that have nothing to do with one another. Whatever you do with p, you don't have to worry about q at all. Q is going to do its own thing, p is going to do its own thing, because they are completely different bases. So that's why when q has the negative exponent, the way I get rid of that negative exponent is I move q to the bottom. P is just staying where it is. P hasn't done anything. P is sitting there, it's got the 2, it's not bothering anybody, it's minding its own business. So P stays exactly where it is. Q, on the other hand, has that negative exponent. So Q, with the 10, has to move down to the other side. Again, they are separate variables doing their own thing. All right, so now, Now I can worry about the exponent. Now that I have the exponent, it's just two terms, and they're on the side of the dividing line that I need to worry about. They're on the right side of the dividing line, so I don't have to worry about negative exponents anymore at all. I don't have to worry about p interacting with q, q interacting with p, not that I did before, but I don't have to worry about any of this. All I have to do is multiply the exponents. I'm going to multiply both exponents by this number out here. These two are not going to interact with each other ever. So it's going to be 2 times 3 divided by q to the 10 times 3. Because again, parentheses, exponent, that's going to be the only time we ever multiply. The only time we multiply. So p to the 2 times 3, q to the 10 times 3, and that's going to give me p to the 6 over q30, and that's the correct final answer. So again, with what we started with, I suggest that you simplify what's in the parentheses first. So here we use the quotient rule. That gave us this. Now that since we applied the quotient rule, we simplified what's in the parentheses. Now we just do the power rule with each of the variables. We don't have to worry about negative signs. We don't have to worry about moving things around. Everything is exactly where it needs to be, and it just becomes arithmetic. So that's it for that one. So again, even though they look ugly, they're basically just the same. It's the same principle. You figure out what rule to apply first to make it easy, then you figure out what rule to apply next to make it even easier, and then finally you usually bring it down to the last rule, which is just the easiest rule to apply of all. Oh boy. All right. This one could get worse, not by much, but so again, we have x to the fourth times y to the negative third in parentheses raised to the third power. That is times e to the fifth, and they are all divided by x to the eighth times y to the negative fifth times e to the negative squared. So we got a couple ways to do this, but what I'm going to suggest that we do is we get rid of those parentheses first. Because they are inside the expression, they're preventing us from doing the quotient rule, because we don't know how many x's we have on top, we don't know how many y's we have on top. So we can't separate out the terms and use the quotient rule to simplify things even farther. We're going to end with the quotient rule, because once we know how many x's we have and y's we have, we're going to have an x and y and a z up top, we're going to have an x, y, and z on bottom. We're just going to subtract them. We're just going to subtract the exponents and see where things lie. So first things first, I'm going to get rid of this exponent, get rid of this parenthesis. So again, when you have two variables inside parentheses, you're going to apply the exponent to each of the variables. The variables are not going to affect each other at all. This exponent is not going to affect this exponent. This variable is not going to affect this variable because they are two completely different variables. X and y are completely different. So all that means is we've got x to the 4 times 3. So I'm taking x to the inside of the parentheses times the outside, because this is the only time we can multiply, times y to the negative 3 times 3. Notice again, I'm just writing down the powers as they are. Whether they're positive or negative, I will worry about that later. First things first is I have to set up the operation. So that gives me x to the 12 times y to the negative 9. All right, we have worked out what is inside the parentheses. All right. Like I said, we've worked out what's inside the parentheses. Now, as you can see, it's just a quotient of power rule. We've got the division sign here, so we know we are going to subtract. So what I'm writing down here, I know that these are my three bases, so these are the three bases I'm going to keep track of. Start with x. X to the 12 divided by x to the 8 equals x to the 12 minus, and now I'm going to see what the bottom is, 8, which is going to give us x to the 12 minus 8, which is 4. So that puts x to the 4. All right, x's are done. Let's keep the ball rolling. Y's are a little bit more complicated, but we got y to the negative 9 divided by y to the negative 5. But again, whenever we're applying the quotient rule, whenever we're applying any of these rules, the rules themselves are meant to take these complex operations, these complex figures, and basically reduce them down to an integer operation. So if you can do 1 plus 3, you can do advanced exponential ideas. So again, I'm just going to write them down exactly as they appear. Negative 9 minus, now that I've written down negative 9 minus, that's the quotient rule. Now I'm going to write down this number as it appears, negative 5. Now that I've written everything down, now I'm going to sort out the positive and negative. Now I'm going to fix this so that it becomes an operation I can actually do. Equals y to the negative 9 plus 5. Because if you subtract a negative number, it turns it into a plus. So negative 9 plus 5 is going to give me negative 4. That's why. The last one is z, so that's z to the fifth divided by z, it's minus 2. So once again, I've got z, and I'm going to take the fifth first minus. Now that I've got 5 minus with the quotient of power, I'm going to take a look. Now that's negative 2. Again, if you subtract a negative number, that gives you 5 plus 2. Again, if you subtract negative number, turns it into a plus, so 5 plus 2, which gives me z to the 7. Now, as I've mentioned a couple of times in class, this will give you the 90% correct answer, maybe 80 depending on how irritated I am when I'm grading. But we can't have any positive numbers. We can't just turn this into positive 4. What we have to do is we've got to move this to the other side of the gate. We've got to let the animal out to the other side of the gate. We let the animal out on the other side of the gate, and it becomes very happy. It becomes positive. We have to do this in order to make the exponent positive. Can't just turn it into positive 4. We've got to move it to the other side of the dividing line, or the other side of the gate, in order to make it positive. Now we've got these bases here. This is the final correct answer. So again, we started all the way up here. I suggested what we do is we get rid of the parentheses in the exponent first. That way we know how many x's and y's we actually have. We found out how many x's and y's we actually have. Then once we did that, we used the quotient of power rule and got our final answer here. All right. Last one. Alrighty. So this is the last one on our crash course of examples. This one, what I'm going to do, I'm going to take care of the parentheses and the exponent first before I talk about what we're going to be doing with this next operation. So again, I've got a to the third, b to the third, raised to the third power. So that's this expression here. As I've mentioned several times by now, a and b are not going to mess with one another. They're not going to do anything to affect the other. So whatever this exponent is, we're not only going to multiply, because this is the only time we can multiply, but we are only going to multiply this exponent with the terms inside this set of parentheses. So that's going to give me a to the third, third, times b to the third, third. So I'm just separating out the variables and raising each one to the third power. So what that's going to give me, it's going to give me a to the 3 times 3 and b to the 3 times 3, which is 9. So it's going to give me a to the 9 and b to the 9. I'm just going to write it down on the next step on this equation here. All right, now from here, we've got two different options. But what I want to do is I want to make this as easy as possible in order to help solve it. So this dot here just means it's multiplication. Because it's multiplication, that's nothing new. What it means is that we can combine these two together. And so that's going to give us that's really all it's going to give us, is one solid expression of a bunch of things up top and a bunch of things on bottom. Well, excuse me, we've got a and b as our variables, but we've got too many a's up top and too many a's on bottom. We've got too many a's up top, too many b's up top, and too many a's on bottom. So what I'm going to do, I'm going to combine them together, because these are all combined with multiplication. So what that means is I can do this. I'm going to do it the same way down here because these are also combined by multiplication. So what I'm going to do, now that I have everything combined as a like term, I'm just going to do the top, and then I'm just going to do the bottom. And whatever the top turns out to, I'll deal with that later. Whatever the bottom turns into, I'll deal with that. So I've got a base times a base. What that means is I can add their exponents together. So that gives me a to the 12. There we go. So again, base times a base, that gives me -2 plus 9, because again, if I'm doing base times base, I'm just going to add the exponents. So -2 plus 9 is going to give me 7. Now I'm going to do the bottom. I have two a terms, so I'm just going to add them together. A to the 1 plus -2 is the same as a to the 1 minus 2, which is a to the -1. And then there's only one b here, so b to the 1. All right, let's see, where can I do this? So I'm going to rewrite it so that we're dealing just with this one. If you need to see these middle steps again, just rewind the video. All right, now that I've got an A up top and an A on the bottom, I've got a B on top and I've got a B on bottom. Now I'm going to do the quotient to power rule. Final of our 3 rules, but now it is the easiest rule for us to apply because we have the A's separated, we've got the B's separated. We know the A is only going to affect the A, and we know that B is only going to affect the B. So let's just write out the quotient rule as we got it. So again, quotient rule, a to the 12 divided by a to the -1 equals a to the 12 minus, now I look down at the bottom, -1. As I've mentioned before, if you subtract a negative number, it's the same as adding a positive number, so that gives me a to the 13, or a to the 12 plus 1. Now let's take a look at the b's. We've got b to the 7, or b to the 1, equals b to the 7 minus, again, b to the 7 minus, now I'm going to look down here, 1. That gives me b to the 6. And there you go. That is our final, absolutely fully simplified answer. It was one where we used all 3 rules in sequence. We had to, at some point, we had to at one point or another. We knew that we had to get rid of the parentheses and the exponent first to figure out how many a's and b's we actually had. This multiplication sign just means that we can put these two together as they appear. As soon as we did that, we're like, oh, we've got too many a's, we've got too many b's up top. We'll use the product of power rule, which we did, which got us right here. It got us all the a's up top, got us all the b's, got us all the a's and b's up top and a's and b's on bottom. Then all we had left was the quotient rule, which is subtraction, and we knew that because of this little sign here. Eventually we got the final answer, and that is the final answer. So hopefully this crash course has benefited you. Hopefully you kind of read between the lines kind of what I was going with this. So yeah, best of luck to you if you haven't taken it already, and I'll talk to you later.